name is Jake Fleischer, and today I'm going to be talking about quantifying local catch from Instagram using a convolutional neural network. Over the summer, I was able to do the John K. and Violet Fellowship, which is a summer program for student research. I'd like to thank Papa Jack again for letting me have this opportunity to do research and make me learn more about CS and convolutional neural networks. So you might be wondering what a convolutional neural network is. And it's basically a computer algorithm that is able to classify images. So for example, if I ran that image through the program, it'll pop out as a tuna. And yeah. Obviously, okay. So these are the UN sustainability goals, and the importance of these goals is that we want to have a better and sustainable world that really helps society move forward. And the UN wants to accomplish these goals by 2030, and they have to have commitment by every single level underneath it. So for Hawaii, there's Hawaii Green Growth. And Hawaii Green Growth is a public-private partnership that stewards Hawaii's sustainability goals. And they do this by the Aloha Plus Challenge. And that really helps to model the implementation of the sustainability goals. So the Aloha Plus Challenge advances social, economic, and environmental priorities for the state. They also use a thing called a dashboard to be able to physically track the data and see how far along they are to reaching their goals. So as you can see, there are 6 categories for Aloha Plus Challenge, and I'll be focusing on the green field over there, food production. And one of the targets for food production is protein. And because we live on an island, a lot of our protein comes from the ocean. So there's a lot of fishing. I'm sure you all know like an uncle or auntie who fishes here and eats their own catch. So there's a huge culture for non-commercial fishing. And because of that, there's a data gap for non-commercial fish because you can't really be able to catalog every single fish you catch, and there's no mechanism to capture this currently. So to estimate how much non-commercial fish count there is, Hawaii Green Growth uses the Hawaii Ocean Health Index, and this is an index that rates each county of Hawaii by the healthiness of the ocean. So they use 6 categories, I believe, and one of them is food provision. Food provision is basically what fish are being caught, and if you can see this table, I don't know if it's too small or not. It shows each category of fish caught and also the amount of pounds that were recorded. The categories are reef, bottom fish, coastal pelagic, and pelagic. They do this they get the actual count of pounds using a survey called the Creel survey. This is a 2-part survey, one being a telephone and an intercept. Will make sense. The telephone survey is a random sampling of households in the state, and they call them up and ask each household, or the head of the household, if they have fished in the past 6 months, I believe, and what are their fishing habits over their years. For the intercept, they actually go on site and on the shore or in the ocean to find how many fish the fishermen have caught and what equipment they use. So they get all this data and put it into a formula that they developed themselves, and they get a rough estimate of how many fish are being caught. So I think the problem with this type of surveying is that it's kind of based on assumptions on the fishermen, and it's mostly an estimation instead of a concrete number. So I wanted to find a way to have a more concrete and better defined data for non-commercial fish catch. So my plan was using Instagram, a site where you can post pictures, and using images that fishermen have taken of fish as a concrete source of data, because it physically shows the fish they caught. And so I'll grab the image from Instagram, and then from the picture I'll get data like where the picture was taken and which user was taking the picture. And then through the picture I'll run it through a convolutional neural network, or CNN for short, a classifier which examines the image and sees what species of fish is in that picture, and I'll put that into my spreadsheet. From there, I'm gonna examine the image more just to find an accurate count for pounds. Okay. So as you can see here, this is just an example of an Instagram post of a fish, yellowfin tuna, I believe. Okay. And what I want to capture from this screen is the user, the tags they used, and also the image of the actual fish. And it just highlights. So I was planning to grab each Instagram photo by their hashtags. So I'm gonna, I just messed up. Here's a sample of what I want as like a final spreadsheet of all the data. But I did this by hand, so that's why it looks so organized. So the first column is the user, next is the county, date, number of fish, type of fish, pounds, species, and then after that there's like a lot of rows of hashtags they used. So that's what I want as a final product. To grab the actual image, I'm trying to use an Instagram API, and what an API does is basically a developer tool to manipulate how to get Instagram data. So from this example, this is not what I wrote, but it uses an embedding system and this one gets the latitude and longitude of a location and finds all the images and the data along with it. So I want to use a hashtag embedding system to get all the images under that hashtag. So after I get that, I can use the ID to download the image and run it through a convolutional neural network. So this is a basic structure of it. For mine, I'm gonna have an input, which is the image, and the image is made out of a lot of pixels, right? So what a convolution does is that it gets a certain portion of that image and basically rates the image by like a pixel. It's kind of hard to explain. A pixel value. So just imagine that each pixel has a value in it. And then what a pooling does is that it pools all those values of those pixels into a matrix, usually like a 9 by 9, for example. And then a ReLU is basically a equation that puts all those values into a range between 1 and 0. So it's simpler for the computer to understand. And after that, it compares it to the test matrix and sees how much percent it compares to, and if it matches a lot, like 99%, it's able to classify that image. So here's just a sample of the main code. This is basically adding each step or layer to figure out what type of image that is. Okay, so my program unfortunately isn't 100% running. I was able to get a testing system, so it's able to test the image, and that's like all the test images that I used, but it can't fully get the correct shape into the program, so it's like malfunctioning or it's having an error. And Um, yeah, so I'm still trying to work on it, but it's pretty close. I just have to get the right operating system to have a fully working convolutional neural network. So my future plans is to have the have the API working as well because I'm kind of restricted in sandbox mode. Okay, and then also have a way to transfer images from the API to the program without downloading the image because I think I have to download it before, and I don't want to use a lot of data to just move all those images, and also to make my program work by again having it. Oh, and then also have a file that has all the matched photos so I can collect the data. So my reflection is that over the summer I learned a lot of computer science, especially machine learning and how all that works, and it's a lot of math. It took a lot of time and effort. I had a particularly hard time doing this and figuring it all out. And I also wish that I had someone to like work with because there's a lot of problems I encountered, and I want to like have a new like input as to see like what solutions I could have done because I don't think what I did was efficient. So thank you. I would like to thank my mentor, Chelsea Harder, the computer, or the one on the computer, for guiding me, especially through what I wanted to do and how to collect the data. And also like to thank Dr. Chan, who guided me through this process because it was kind of complicated, and also Papa Jack again for giving me this opportunity. And also like to thank all of you, especially the boys, for for coming because I thought it would be empty, but it's full. So thank you. Thank you. Yes. So I was trying to look through how to get like all these images, and Instagram was like the easiest option to grab all the data because you can actually get the image straight from the API. But like other stuff like Twitter or Facebook, it's kind of harder to actually get the image. Yes. Oh.
Screen test? Oh, so yeah, so I basically did the same thing that I did when I was trying to find a qualitative value of deforming virus in the sample or not. So I ran all the samples, all the positive samples for deforming virus through the RT-PCR, through the gel electrophoresis. I added like the right primers and the specific primers for strain A, B, and C, and then I tested. Actually, I tested for A and B because C is very, very rare. And I found which ones were positive for A and B. Yeah. Yes.
How many B's did you have to do?
It was around 30.
So 30?
30.
But you were worried that amount, the number of B's would be
The native
yeah.
populations. Just because you have to be cautious when you're working with endangered species because there are a lot of permits and regulations that you have to go through. And there's a much larger population of non-native hylas than native hylas.
Has a burrow been found on any of the yellow-faced bees?
I did not find them on mine, but I think they like to stick to the honeybees. That's why the transmission rate is so high in honeybees. Like they're specifically known for transmitting the disease to honeybees.
So this is for both of you, and at school we always talk about being lifelong learners. So what's a lesson that you took from your research or maybe from the process that you're going to apply to your life, learning, whatever you want to call it,
Okay, I'll start. I think one of the things I learned is that it's like way more solutions than what you think originally, because my original plan was a bit different from what I finally did, and I also am trying to find other solutions as well, even through what I have, to find better ways to actually capture the data. Yeah.
I think that my takeaway is having a group of people like around you that know a lot about something that you're pursuing or want to support you and help you throughout the process makes it a lot easier than if you're just kind of on your own. That's not a joke, but it definitely made my research much easier than a lot of the papers. Yeah.
It's good. It's
Sorry,
good.
this is kind of a little bit off topic, but do you know approximations or
I,
anything in the works?
I haven't looked into that. I'm sorry. Yeah.
We have time to answer that question? This is our first bell. Oh, okay, yeah. So, this is for an answer. They did speculate that
It's my
different
mentor.
strains of the virus that before they knew that it was detrimental, that they could connect it with a more detrimental A strain, but then they found that B is actually the virus itself also recombinates within an organism, so even if you it itself could mutate.
Um, it really depends on how like accurate or how realistic those fake pictures look, but probably not. It's yeah, right now. Yes. I have not, but it could certainly be used for different systems. So the location, the person has to state where they caught it. So you know how you can put a tag of like where you caught it. For the pounds, I'm still trying to figure out a way to accurately count that, because my program can only classify what type of fish, but not really the actual poundage of that fish. Yes.
How accessible was the program that you used? Because it sounds like really useful. And if anyone wanted to identify anything from like category of Instagram, it sounds like I didn't even know this technology existed. So how accessible is it?
There's a lot of, I'm sure there's a lot of programs already that do identify certain objects. So the actual, I think the hard part is actually getting like an image and then just running it through it, because I have to like type in a lot of manual code just to put an image through it.
I guess what I'm asking is what program
Oh.
did you use to
Oh,
start
so
what you did?
I actually had like, there's a person, there's a not program, a library called Keras, which is used primarily to not fun, it's not hard word, to run a convolutional neural network. So I used that and then had code to just, I did like use another person's code to get the image as the correct size and format, and then just write that code to get the layers. Yeah, it's complicated.